Here we have a calorimetry problem where we have a chemical reaction taking place inside a calorimeter, and we want to figure out the heat in kilojoules per mole of AgCl formed. This is from page 278, number 59, Zundel 8th edition. In a coffee cup calorimeter, 50.0 milliliters of 0.100 molar AgNO3 and 50.0 milliliters of 0.100 molar HCl are mixed to yield the following reaction. Ag plus aqueous plus Cl minus aqueous yields AgCl solid. The two solutions were initially at 22.60 degrees C, and the final temperature is 23.40 degrees C. Calculate the heat that accompanies this reaction in kilojoules per mole of AgCl formed. And the heat capacity of our solution, we're saying, is the same as water, 4.18 joules per gram degree C. And we're saying that the mass of the solution is 100 grams. So we're taking 1.00 grams per mil for the density of the HCl and silver nitrate solutions. So a total of 100 mils would give us a total of 100 grams of solution. So in this problem, we have an exothermic reaction that is releasing heat and raising the temperature of the solution. So if we take our two solutions as our system, there is heat being transferred within the system, but no heat leaving or coming into the system itself. So the heat that the reaction releases, the delta H of the reaction, plus the Q of the solution equals 0. So the delta H of our reaction plus the Q of the solution equal 0. So the heat that's released and the heat that's absorbed by the solution is for these particular quantities. So we're going to calculate that delta H first, then we'll figure out what it is per mole of AgCl formed. So we can say that the delta H of the reaction, what we're looking for, is equal to the negative Q of the solution. So the delta H of the reaction is equal to negative the mass of the solution times the heat capacity of the solution times the delta T of the solution. So that is negative. The mass of our solution is the whole mass that rose in temperature, so that is 100.0 grams. The heat capacity, 4.18 joules per gram degree C. And then the delta T is the final temperature, which we have here as 23.40 degrees C, minus our initial temperature of 22.60 degrees C. And I'm just going to subtract that, and we get 0.80 degrees C for our delta T. So now we do our calculation, and we get the delta H of the reaction is equal to negative 100 times 4.18 times 0.8 equals. So we get negative 334.4, and our unit is joules. And I'm going to calculate the sig figs later. I know that this, I'll put a little note here, should have 2 sig figs, but I'm going to leave that go till later. So now this is the heat that gets released for the amount of the chemicals that we combined. So what we need to do now is figure out how many moles of AgCl were produced when this amount of heat was released. So we go back to our reaction, and we have that the Ag plus the Cl minus yields the AgCl. So I'm going to do an ice table here, since we're giving the amounts of both of our chemicals. So 0.1 molar and 50 mils means we have 0.00500 moles of Ag plus. There's one Ag plus for every one AgNO3. And then for our Cl minus, we have the same, 0.00500 moles of Cl minus. And they're both the same. We have a 1-to-1 ratio, so we lose the same amount from each. And we get 0.00500 moles of AgCl. So this is what I am interested in, the moles of AgCl that we have at the end of the reaction. So now I need to figure out the heat in kilojoules per mole of AgCl formed. So my units that I want are x joules per mole of AgCl. So my joules, negative 334.4 joules over 0.00500 moles. And get my calculator. And I'm going to put that in kilojoules. So I get negative 67 kilojoules per mole of AgCl. There's my final answer.